University in 2018 for offering value for money education by India Today. With a hygienic mess named Annapurna, well-furnished hostels with single and double rooms, mechanized laundry, 24/7 water supply, complete power backup, and Wi-Fi connectivity, we ensure that students feel at home while they're away from home. The overall growth in personality and confidence is taken care by conduct of debates, declamation contests, and a host of indoor and outdoor games. NCC Wing for Girls and a vibrant youth club that organizes popular sports festival called Padakram, literally festival and cultural festival, which further heightens their energy levels. They're also encouraged to develop independence in thought and action, as well as trained to deploy appropriate technology paradigms for given tasks, explore new horizons, and lead teams to solve complex problems. With our learner-centric educational process, students are free to find their own paths and learn their way to limitless opportunities that awaits them. So be a part of JP University of Information Technology, Vagnakot in Himachal Pradesh to be the leaders in innovation, entrepreneurship, creativity, and management. Because this is where we engineer lifelong learners.
The Indian Geotechnical Society, which was earlier known and founded under the name of the Indian National Society of Soil Mechanics and Foundation Engineering, was established in 1948. This came soon after the Second International Conference on Soil Mechanics and Foundation Engineering held in Rotterdam. The society was affiliated to the International Society in the same year, and since then it has strived to fulfill and promote the objectives of the International Society. The name Indian Geotechnical Society was adopted in 1970. The vision of the founding president, Mr. Khosla, and the honorary secretary, Dr. N.D. Gulati, was to build the society to promote cooperation amongst engineers and scientists for the advancement and dissemination of knowledge in the fields of soil mechanics, foundation engineering, soil dynamics, engineering geology, rock mechanics, snow and ice mechanics, and allied fields and their practical applications. As the geotechnical community started to grow, the International Society decided to have regional conferences for each continent, along with having 4 yearly international conferences. This is when the first Asian Regional Conference was held in 1960 in New Delhi. India also hosted the 5th Asian Regional Conference at Bangalore in 1975 and the 13th one at Kolkata in 2007. IGS has been organizing national conferences annually in different cities since 1961. The Silver Jubilee Conference was held at Kurukshetra in 1973. 1978's GeoCon was a landmark conference held at IIT Delhi, which was inaugurated by the then Prime Minister Morarji Desai. IGS started the prestigious annual lecture in 1978. A tradition followed till date. The first one was delivered by Professor R.K. Katti. Several others who delivered the annual lectures include Professor Dinesh Mohan, Professor T. Ramamurthy, Dr. R.K. Bhandari, Professor Gopal Ranjan, Dr. B.G. Rao, Dr. N.V. Nayak, Professor G.V. Rao, Professor A.V. Shroff, and most recently, Professor M.N. Viladkar. IGS made an impressive debut in the international scene in 1994 with the organization of the 13th International Conference on Soil Mechanics and Geotechnical Engineering that was held in New Delhi. This was one of the biggest conferences in the history of the International Society, and it firmly put India on the international map.
24 years ago, in 1994, the Indian Geotechnical Society organized the 13th International Conference on Soil Mechanics and Foundation Engineering in New Delhi. This conference was a great success. Everything went perfectly as planned. Its technical sessions, its exhibition, its field trips, its delegate interaction, its companions program, its entertainment, and hospitality. Dr. Parry, the Secretary General of the International Society, in his concluding remarks, branded the conference as the Magic Carpet Conference.
The turning point came from the 12th Annual Regional Conference in Singapore, which saw more than 20 Indian participants and the keynote lecture by Professor Madhav. We were successful in winning the next ARC at Kolkata and also Professor Madhav as Vice Presidentship for Asia for the term 2005 to 2009.
The major visible contributions from Indian Geotech Society have been in the latest 21st century. A large contingent had attended the Singapore Asian Regional Conference, followed by election of Professor Imran Madhav as the next Vice President for the term 2005-2009. Several of our members have been, members of IGS have been members of the technical committee, and the most recent achievement of our society has been the keynote lecture or plenary lecture given by Professor Babu at the Seoul International Conference. With the kind of enthusiasm and activities of the Indian Geotechnical Society and its members, I look forward to a much more greater role for IGS in the international community.
The Golden Jubilee Conference was held in 1998 at Delhi. IGC has hosted the council meeting of ISSMGE at Bangalore and the 6th Asian Young Geotechnical Engineers Conference very successfully, thanks to great efforts by Professor Sitaram, Professor Srinivas Murthy and the team. IGS was successful in bidding for the 6th International Conference on Environmental Geotechniques to Delhi in 2010, which was a great success with due to Professor Manoj Datta's great efforts. The international community has become aware of our true potential, with several of our members becoming active in several technical committees of ISSMGE. IGS has a full-fledged office in New Delhi, catering to the needs of its members. IGS publishes a quarterly journal since 1962. It is now accessible online to all IGS members free of cost. Since 2012, the journal is being published by Springer for qualitative improvement and international reach. It has wide circulation and is retrieved internationally. IGS also publishes a quarterly newsletter to keep its members abreast of all geotechnical events. IGS operates through its local chapters that keeps its flag high in different cities of India. With 44 active chapters, IGS has spread its reach to every part of the country. Some of the active local chapters include Delhi, Roorkee, Mumbai, Indore, Pune, Goa, Surat, Bangalore, Chennai, Kolkata, Guwahati, and several others. To encourage the chapters, an annual Best Chapter Award was instituted in 1995. The Delhi chapter has won this award a record 5 times. The geotechnical industry in India is incomplete without its partnerships with geologists, earth retention system contractors, consultants, and public sector organizations. Institutions like the IITs, CSMRS, CRRI, CBRI provide industry-academia interaction so that the benefits of research reaches the industry and the industry can input to the academia, what the trust of the research should be. This helps in directly applying the findings of the research on the ground for real implementation. With the growing demand for land, we have skyscrapers sprouting up in every big and small city in India. As industries grow, demand for power and power plants also increases. Connecting the industries through bridges, highways, railways, and metros, the Indian geotechnical landscape only shows a promising future. This also means that there is a demand for quality work as the margin for error is nil. Today, IGS is working towards setting up a joint assessment for testing soils along with the National Accreditation Board for Laboratories, the NABL, to match the quality of testing with the international standards. IGS is also working with the Bureau of Indian Standards to prepare Indian standard codes in several aspects of foundation design and field and laboratory testing. Many of our members serve in these committees.
The future is very bright and full of optimism. A number of initiatives have been taken up, promotion of student chapters in various colleges and institutes to sensitize the students about the importance of geotechnical engineering in their curriculum and the practice. Creation of number of professional groups to make them aware of the future challenges and opportunities in geotechnical engineering. A number of initiatives such as interactions with other professional groups that are overlapping with geotechnical practice are also initiated. It's hoped that with all these initiatives and further initiatives that one can have at IGS level, there could be better geotechnics in the country, which ultimately to better, cleaner, sustainable societies.
The future of geotechnical engineering lies in the hands of today's students. Recognizing this, IGS has set up student chapters in some cities, several more in the offing. As we celebrate the 70th year of the Indian Geotechnical Society, the possibilities that we look forward to are limitless. Here's to saluting the past, celebrating the present, and welcoming the future.
This video was actually made in 2018 to celebrate 70 years of IGS. Of course, now IGS is 73 years old, and in 2 years we'll be celebrating the Platinum Jubilee. So that will be a big event, which we all look forward to.
Yes, sir, definitely. So thank you everyone for being a patient listener. It's really because of those great people and the work of those great people, whether academicians, researchers, or industry people who have reached the IGS to these heights. And we are really thankful to IGS for providing this great platform where we can readily share our knowledge with each other so easily. So with this note, we will further progress onto the inauguration ceremony of the event. So first of all, I would like to invite and welcome Professor Dr. Ashish Kumar Rohila, HOD of Civil Engineering Department, and one of the initial joining members of IGS Shimla chapter, to kindly share a few words with us.
Thanks, Neeraj, for giving me opportunity to talk something about the geotechnical engineering. Good afternoon to all of you. And on behalf of Department of Civil Engineering, I warmly welcome all of you in this webinar series, Advanced Testing Technologies for Geotechnical Investigations, that is jointly organized by Department of Civil Engineering and Indian Geotechnical Society. We are grateful to our speakers of the session. Presently, Mr. Ravi Sundaram ji is Director of Cengrs Geotechnica Private Limited. We are thankful to you, sir, that you have here for sharing your words and what you have done in this field. So I believe that we all will get benefited with your kind words and what expert things you have done in the field of geotechnical engineering. So, well, a geotechnical engineering is a very vast area and needs no introduction. And as we have also seen that the Indian Geotechnical Society has done a lot of work in last 70 years, and that is very great. And we all know that a geotechnical engineer is basically a bone. That is basically what we see, that every structure we create needs a foundation. Like, so we see that a geotechnical engineer is basically a foundation of any engineering, is a foundation of any structure. So he is involved from the start, from the conception of any idea of the structure. And if we see that a geotechnical engineer is involved basically in investigations of the subsurface conditions and materials, like what is the soil, what is the rock strata, and then finally how we can design our structures, like retaining structures. We are working for the dams, embankment dams, then we are working for the tunnels, and nowadays we can see that highway structures are going on in a big way, and we are designing the numbers of tunnels. So in this way, what we see that role of a geotechnical engineer is very, very much important. And as such, as we have an era of the instrumentation and the automation, and that's what we see that our techniques for the experimentation and finding the various physical or chemical parameters of the subsurfaces that have also upgraded. Now we see that the research also indicates that now civil engineer, particularly that our geotechnical engineers are making use of artificial intelligence and machine learning in order to find out the various parameters. So that is very really good thing that we as a civil engineer are also working and also popping up with the new latest technologies, and we are incorporating all these things. So that what we have with us, that Mr. Ravi Sundaramji, that is giving us the idea about what advanced testing technologies we are using in presently in the field. And I hope that our listeners, and whether it is from the industry, whether it is from the academics, whether it is the students, they will all get benefit from his expertise in that area. So with these words, I will not take so much time, because already we are running, we are also consumed 30 minutes. So thanks, and I hope that our listeners will get benefited with this. And lastly, I am thankful to our Vice Chancellor, Professor R.K. Sharma ji, and our Professor Dr. Ashok Kumar Gupta. He is presently Dean, Academic and Research, and he is also a good geotechnical experts, and he is also having a vast experience in that area. I am thankful to both of them that they have provided us opportunity to conduct this webinar session. And lastly, Mr. Neeraj Singh Parihar and Rohan Singhal, they have done a good job in order to organize this event, this webinar session. So with these words, I hand over the session to Neeraj again to kindly continue this. Thanks.
Thank you, sir. Thank you for your nice words of appreciation. With this, next I would like to invite and welcome Professor Dr. Ashok Kumar Gupta, Dean Academic and Research, JUIT, and Chairman of igsshimla chapter, to kindly share few words of wisdom and also declare this event as open. Over to you, sir.
Honorable Ravi Sundaramji, Director from Cengrs Geotechnical Limited, New Delhi. Our HOD in Civil Engineering Department, Professor Ashish Kumar. The man behind this, the two-person behind this workshop, Mr. Neeraj and Rohan Singhal, Actually, they did a lot of work. All the participants here, my dear friends. Actually, for any event of this size, I should thank the people who will going to or whosoever is the responsible for doing all this. Actually, I should thank civil department that he help us, civil engineering department, JUIT Vaknagar, that he has taken up this call that okay, we help IGS Shimla chapter to this activity, and Ashish did lot of help in this case. I also thank Rohan Singhal and Neeraj. They took up the challenge and they do all the work. Actually, all the behind the scene work is done by these two gentlemen. So I am thankful to them. And with the permission of all present here, all the participants and Ravi Sundaramji, I declared this event open. Let God help us that this event go through very well. And I am hopeful that it will be a successful grant. Thank you so much.
Thank you, sir. Thank you very much. So thank you, sir. Now the event is open to everyone, and we will be proceeding through the next round, that is the lecture session round. So now on the behalf of the entire JUIT community, Civil Engineering Department, JUIT, and IGS Shimla chapter, we would like to welcome our geotechnical expert, speaker of the day, Mr. Ravi Sundaramji. Welcome to you, sir. And it's a proud moment for all of us to have you here on this platform of IGS Shimla chapter. Now, giving a brief introduction about him, Mr. Ravi Sundaramji, BTech in Civil Engineering in 1978 and MTech in Soil Mechanics and Foundation Engineering in 1980 from IIT Delhi, is a person of high repute both in the field of industry and academia. He is currently the founding director of Cengrs Geotechnica Private Limited and also the fellow of Indian Geotechnical Society. Starting his career with McKellen Engineers USA and working at various official locations in Saudi Arabia, Qatar, and UK. Mr. Ravi Sundaramji became the founder director of Cengrs Geotechnica Private Limited, which was established in 1990 by IIT Delhi graduates. Now, this is one of the leading geotechnical private organization in India as well as abroad. Mr. Raviji directs the company's geotechnical consultancy services as well as the geotechnical construction activities. His expertise includes geotechnical investigations, geophysical surveys, ground improvement, and groundwater studies. He has been actively involved in developing the engineering solutions to problems of foundations under artisan conditions, collapsible dune sands, soft clays, expensive soils, and many more. His special interest lies including the geotechnical solutions for foundations for tall buildings, thermal and solar power plants, and bridge foundations, besides testing of pile foundations and strengthening of weak and distressed foundations. Now, above all the industrial experience he has also significantly contributed in the field of academics and research, where he has published more than 70 quality research papers, reflecting his true experience in geotechnical practice. He has strived to integrate the field experience with the academic research in order to be responsive to complex geotechnical challenges faced in India. He is also the co-author and co-editor of two very renowned books. One is Geotechniques for Transportation Infrastructure, published by Springer Nature in 2019 from Singapore. And another one is Retrieving the Lost Paradise, Celebrating the Earth Day, published by Northern Book Center, Delhi in 2001. Talking about his achievements, Mr. Ravi Sundaramji has a number of accomplishments and awards to his name. To name a few, he received Professor Dinesh Mohan Memorial Award in 2017 and 18 by IGS for excellence in professional practice. He also delivered the prestigious 6th Mahadev Lecture in honor of Professor Mahadev in 2017 on geotechnical investigations in difficult soil conditions in Indian experiences. He also received the IGS Delhi Chapter Lifetime Achievement Award in 2012, and he is the active member of both BIS and IRC code committees. He is also the member on Transportation Geotechniques, ISSM GE, and also working as executive committee member of IGS main body at present. So with this note, I would like to invite Mr. Ravi Sundaram sir to kindly take the main stage and request him to proceed with the first lecture of this geotechnical webinar series, Advanced Testing Technologies for Geotechnical Investigation. Over to you, sir.
Thank you, Dr. Parihar. Really grateful to you for that introduction. At the outset, I would like to thank IGS Shimla chapter and JUIT for inviting me, Cengrs, to organize this event. A series of 7 lectures is 5 lectures is something which really special for us to organize, and we are really grateful to you that Cengrs has been invited to deliver all these 5 events, 5 lectures. So I am now sharing my screen. Able to share.
Sir, you can kindly share your full screen. I mean your entire screen.
Okay, let me try again. My entire screen, but it's not showing my presentation. Oh, it's only sharing the.
Yes, sir. Now your screen is visible.
Can you see my screen now?
Yes, sir. It's now visible.
Is it on presentation mode?
No, still not, sir.
It's not.
Sir, are you presenting entire screen?
Yes. I'm presenting a window.
No, sir. You have to present the entire screen. Then only it will go to the presentation mode.
But on the entire screen, it's only showing the screen of the presentation, the lecture here. It is not going to my presentation.
Sir, once you will click on that, next you can go anywhere onto your presentation mode also.
Okay.
You just need to click once there and press share.
Now can you see my screen?
Yes, we can see your screen, sir.
And you can see my presentation?
Yes, now it's correct, sir. It's okay now.
Is it on presentation mode?
Yes, yes, sir.
Oh,
It's
great.
fine.
Okay, so this first lecture today is on an introduction to advanced testing technologies and geotechnical investigation. So can you see the screen here? Yeah, great.
Yes, sir.
So this first lecture is on introduction, and then the next one will be on static cone penetration test by Mr. Saurabh Gupta. Then Mr. Sanjay Gupta will be presenting on pressure meter tests in geotechnical design. The fourth one will be by me on geophysical testing. And the last one, energy measurement for SPT. This is the latest technology which is now being adopted in India. This will be presented by Mr. Ankit Unyal. All these technologies will be illustrated by case studies to demonstrate the field application and the engineering benefits you can get by using these technologies. So as you know, modern geotechnical engineers have a vital role to play in today's world. They have to face numerous challenges to solve various problems regarding space utilization, underground construction, highways, industry, power sector, thermal, hydro, solar, infrastructure development, hill area development, difficult strata conditions, and many more. This list goes on. The challenges of modern construction include tall buildings, 50 to 100-story buildings, multiple basements, power plants, heavily loaded industrial buildings, variations in ground profile, particularly metros, highways, and railways. When the ground profile is different and the stratigraphy changes along the alignment, so the design has to keep changing according to that. Then expansive soils, construction in weak and poor ground, liquefiable soils, fractured rock, hill area development, dams, embankments. The list goes on here also. So geotechnical investigation, of course, is a vital part of all geotechnical studies. It generates important field and laboratory data for foundation design. It's a prerequisite for economical and safe foundation design. Whatever is envisaged at the investigation stage and the design stage, this has to translate into construction that is in sync with the design concepts, the assumptions, and the predicted foundation behavior. Engineers have to come up with solutions for complex problems within a minimum time. So the fast track projects, there is a real challenge nowadays. You have to respond quickly to keep pace with the demands of the fast track projects. Design parameters have to be more realistic. Conventional approaches, it's not just enough to be conservative. You have to go for innovation, safety, and economy. These have to go hand in hand. So therefore, research and development should address non-quantifiable factors and beyond the textbook situations. The field experience of the engineer becomes most important. You have to understand the assumptions and the limitations of theoretical analysis and computer programs based on theoretical concepts. Computer programs, softwares are being used quite a lot, but the limitations and assumptions that have to be clearly understood. The engineering solution which you develop has to be reliable, economic, practical, and amenable to speedy construction. All this within the minimum period. The performance of the structure has to be as was envisaged. So the geotechnical engineer has to consider field studies, success stories, and failures. The approach has to be systematic, flexible, proper choice of geotechnical investigation techniques, and selection of suitable analysis methodology so that you get the right geotechnical parameters. That's very critical. So what it requires is sound engineering judgment. So I'd like to highlight here that geotechnical engineering is a science, but it's practice and art. So this is called the geotechnical pyramid, geotechnical input pyramid. So as you move up along this pyramid from bronze towards platinum, your factor of ignorance reduces, the reliability of the design is enhanced, there's a reduction in foundation cost and construction time, and you minimize the possibility of failure. So let us look at these bronze, silver, gold, and platinum levels of investigation. A bronze investigation would have probably shallow boreholes, very limited testing, whereas you move towards the silver, you have deep boreholes to beyond the pile tip. You conduct SPTs and limited laboratory tests. At the gold level, you have more boreholes, more in situ tests like pressure meter maybe, or maybe static cone penetration tests, lab tests for strength and consolidation, etc. A platinum level would be a more comprehensive investigation with substantial in situ tests in addition to the boreholes. And maybe if piles are required, you could go for static and dynamic pile load tests. The geotechnical engineer in a bronze level would be a limited have limited experience, a non-expert, whereas at a platinum level you have an experienced expert. Similarly, design parameters in a bronze is primarily guessed, whereas in a platinum level it is a site-specific and site-specific. The analysis, design, these are all, as you move from bronze to platinum, you have a optimized design, and the foundations may be over-designed or unsafe or even impractical in a bronze level, and whereas in a platinum level, it's an optimized design, practical to build. There is substantial savings in cost and time. Whereas the risks are low in a platinum investigation. Obviously, the cost is much more, but you should always remember that the amount spent in the investigation, you save much more in the foundation cost. So we must move towards gold and platinum levels, avoid bronze level investigations. The investigation should be tailor-made for the project site as per the site requirements. So involvement of the geotechnical consultant should continue right up to the construction stage. So the investigation methods need to be updated. If you are using SPT, you go for an automatic trip hammer. Energy measurement in the SPT hammer gives greater reliability in the data and the quality of the SPT. So you can see the automatic trip hammer here. You have to supplement it with superior tests like static cone penetration tests, pressure meter tests, etc. And discontinue outdated techniques such as trial pits, dynamic cone penetration tests, etc. Use advanced testing methods. Upgrade to cone penetration test. This would be the static cone penetration test with or without pore water pressure measurement. Pressure meter test, dilatometers, rain shear test, seismic methods, geophysical testing, remote sensing, advanced sampling and laboratory testing methods. So there are various techniques available, but of course we shall be limiting to a few of them only here. The most important thing is to use field instrumentation data for important structures to update the design parameters. Observational method of design based on field observations and instrumentation. If you can implement this, you can do your design very economically. Use advanced analysis methods and softwares are available for analysis. And modern testing technologies is essential for improving the state of art, the state of practice of the geotechnical engineering. So I'd like to differentiate between the state of art and state of practice. So in the state of practice, it's what you actually do there. So static cone penetration test and pressure meter test can justify use of higher bearing capacity for foundations and economize so as to assess the need for ground improvement. SPT measurement can enhance the quality of the data. In some cases, need for pile foundation or ground improvement may be eliminated. Geophysical tests can confirm continuity of the strata, identify anomalous zones if any. Primary and shear wave velocities from seismic tests can be used to assess the shear modulus and Young's modulus. Static cone penetration tests and seismic tests can provide useful data for liquefaction analysis during earthquakes. So advanced technologies will assure higher factor of reliability as against factor of safety. Economical and safe foundation design. It will model the foundation behavior realistically so that the performance of the structure is as envisaged at the design stage. So thus you can add value to geotechnical exploration and enhance the quality of design. So tests covered in this webinar series, cone penetration test using mechanical cone as well as using electric cone with pore water pressure measurement, pressure meter test, and SPT energy measurement. Geophysical tests include electrical resistivity test, cross-hole seismic test, seismic refraction test, and spectral analysis of surface waves. There is SASW test. So just an introduction to the static cone penetration test, the mechanical cone as well as the electric cone with pore water pressure measurement, the conventional cone penetrometer, which is used in the country. This is the mechanical cone system. The 10 ton and 20 ton systems are available. The cone usually has a cross-sectional area of 10 square centimeter and a friction jacket of 150 square centimeter. It has a hydraulic feed and the penetration rate is about 10 to 15 mm per second. So this is the mechanical cone. So you can have a look, details of the cone. So you have the cone here and the friction sleeve here. So in the first, you would push the cone only, and then in the third position, you are pushing the cone and the jacket together, and then this is the total system being pushed to the next level. So normally there is a 5 centimeter penetration here, and then a 10 centimeter penetration, total 20 centimeter penetration. So you measure the cone tip resistance and the frictional resistance. Typical results using a mechanical cone. So you get the cone tip resistance and the friction ratio versus depth. This is a piezo cone. So here you have a pore pressure measurement system here at just above the cone, and you have a data acquisition system by which you can measure the cone tip resistance, the pore water pressure, as well as the sleeve friction. So this is a typical piezo cone. You can see here the pressure sensors and the friction sleeve, and you have at the base of the cone, you have the for the pore water pressure. So the data is collected electronically, connected to a computer. It eliminates human errors. So this is the schematic of the piezo cone. Usually only the U2 is used, although you could have a sensor at this position also. Cones with a cross-sectional area of 10 square centimeter and 15 centimeters square, both are popular. The 15 centimeter square is getting more popular nowadays. The porous element for the pore pressure measurement may be just above the cone or within the cone, as I told you. There is another small variation called the seismic cone with a sensor to measure the shear wave velocity. So that is also being used internationally now. Typical results of the cone penetration test: you have the cone resistance, the sleeve friction, and the pore water pressure. being measured. So soil classification based on the SPT data, you have the cone tip resistance versus the friction ratio. So the low friction ratios indicate sand, and the higher indicates the clay content. And of course, very high friction ratios would mean it could be organic material. This is the interpretation of the CPTU data with the cone with pore water pressure measurements. So there you measure up, compute a pore pressure parameter BQ, and this is related to the cone tip resistance, and you can see these different zones. This classification is done, and similarly with the friction ratio. Correlations are available for cone tip resistance and SPT values versus density. So right from very loose with the cone tip resistance of less than 20 kg per centimeter square to very dense, where you have very high values of cone tip resistance. These correlations are available. And also you can correlate the E values with the QC. The advantages here is that you get a continuous profile of penetration resistance versus depth, and since it is hydraulically pushed, it eliminates the human errors, and borehole cleaning is not required. And if you were to use CPTU or with the pore water pressure measurements, the advantage is that you get enhanced quality of data and elimination of error due to erroneous interpretation due to friction between the inner and outer rods. All these possible errors are eliminated. It's a simple and reliable electrical measurement with easy recording. The pore water pressure effects is very helpful in the foundation design, in the assessment of what kind of behavior it is going to have. But of course, it has limitations. It's not suitable where boulders are met, or if you are having shallow rock, the utility is limited. I move on to pressure meter test. The pressure meter test is an in situ test to determine the stress strains response of this soil. It is performed by applying a pressure to the side walls of the borehole and recording the corresponding deformation. It is akin to expanding a balloon within the soil. Stiffer the soil, the more pressure will be required to expand the balloon by the same volume. So it involves drilling a borehole, placing a pressure meter probe at the required depth, and then expanding it. You measure pressure versus volume change. So the probe consists of two inflatable cells, a measuring cell which expands as it is filled with water, and a guard cell filled with gas. It protects the measuring cell from shocks or impacts. So these are the probes. You have a rubber probe for pressures up to 25 bars, and a metallic probe of metallic outer cover for pressure up to 80 bars. Units up to 200 bars are also available in the industry market. So it's a typical pressure meter control panel, and you can see the probe here being expanded. You can see the center is having a larger diameter because it has been expanded. So details will be discussed in the presentation 2 weeks from now. Typical results. So what you would be plotting is pressure versus volume change. There is first you would expand it in air to check what pressure is required to expand in air, and then you expand it in the soil, and the difference between the two gives me the pressure required to expand in the soil. It is also corrected for the expansion of the hoses by expanding it on a stiff pipe. Typical results. So what you would be measuring, this is called the limit pressure. the maximum pressure that you can apply, and the deformation modulus is a function of the slope of the straight line portion of the graph. So you could plot this versus depth. The in situ stress strain behavior of the soil can be evaluated, and there's a minimum disturbance to in situ soil conditions. Therefore, the quality is superior. Can be done in both soils, hard strata, and rocks. In weathered rocks, where the core recovery is poor, pressure meter test is the only test which can give you realistic data. Bearing capacity analysis and settlement analysis for foundations and pile capacity analysis using pressure meter data gives you more realistic estimate of the actual soil behavior. Of course, every test has its limitations. In sandy strata where the boreholes collapse, it may be difficult to conduct the test. Again, in boulders, you cannot do it. In fractured rocks, the membrane may get damaged if it gets stuck between the fissures. So these are some of the limitations of this test. I move on to geophysical tests. So there are various geophysical tests which are available: electrical resistivity, seismic refraction, cross-hole seismic test, SASW, seismic cone penetration test, MASW test, ground penetrating radar, well logging, magnetic surveys, gravity surveys, etc. In this series of lecture, we will be talking only about the first four: resistivity, seismic refraction, cross-hole, and SASW. So I start with the electrical resistivity test and introduction. So this is the schematic of the resistivity test. You have 4 electrodes usually embedded in the ground. The inner one are the potential electrodes, and the outer ones are the current electrodes. For the Venner configuration, you have an equal spacing of the electrodes. So the depth of penetration of the current is usually equal to the electrode spacing. So you can calculate your apparent resistivity by this correlation here. It can be used as an investigation tool for fast-track projects, preliminary assessment, as well as detailed assessment. In boulder soil matrix, cost and time savings can be substantial. Number of boreholes can be reduced. Used in conjunction with borehole data, it can be used to estimate the stratigraphy and for confirming the continuity of the strata. Electrical resistivity, of course, is governed by Ohm's law. The resistance to current flow depends on mineralogy, particle arrangement, water content, salinity, etc. Resistivity, of course, is a fundamental property of the soil. It is independent of geometry. We'll discuss this in more detail in the presentation 2 weeks later. The current actually flows through the pore water, which acts as a conductor, as well as the soil and rock grains, which may act as a conductor or an insulator, depending on the nature of the mineral. I move on to seismic tests for wave velocity. Geophysical tests based on seismic wave velocities. So these are cost-effective and rapid means of obtaining subsurface investigation. The primary wave velocity and shear wave velocity is a parameter that is used for the analysis. The test may be used to measure the physical properties of the ground, to assess the stratigraphy, design of dynamically loaded foundations, and to assess the liquefaction potential. So the tests covered in this presentation here, I'll just be briefly talking about the cross-hole seismic test, the downhole seismic test, the uphole seismic test, seismic cone penetration test, seismic refraction test, and SASW test. In these tests, the recorded waveforms, the seismic wave velocities, etc., are determined, and from there you determine the various parameters. So start with cross-hole seismic test. So here you have 3 boreholes. This one this would act as the source where you create an energy impact, and you have the parallel boreholes normally 3 to 4 meters apart, and here you have geophones at this level, at the same level as the where the impact is being generated. And what you would do is you would record the time of arrival of the wave at these two locations. So we have 3 boreholes here, and the data acquisition being done. Here horizontally traveling P and S waves are generated in the borehole at the desired depth. Arrival times are recorded at 2 adjacent boreholes. Usually the test is conducted at every 1.5 meter depth interval. You can use the system to test up to 100-150 meter depth. Typical results, so this is the primary wave, and this is the wave velocity for the primary wave, and this is the velocity of the shear wave. So you can see how it is increasing with depth. Yeah. So dynamic modulus, including the dynamics Young's modulus and the dynamic shear modulus, can be determined. There are various other parameters like coefficient of elastic uniform shear, coefficient of uniform compression, non-uniform compression, as well as non-uniform shear. All these parameters can be determined. It's one of the most reliable methods of measuring dynamic properties of the soil in situ. The downhole seismic test is a small variation here. You need only one borehole, and the impact is created on the ground, and you can usually you would have bore 2 geophones suspended at 2 different distances, and from the arrival times you can calculate the hypotenuse distance, and then the vertical, of course, the wave velocity. The uphole seismic test is a test in which you create the impact down here, and you have geophones placed along a line, and normally impact is created on the in the borehole, and you can do the uphole seismic test. This would be similar, slightly different from the downhole. The seismic cone penetration test uses the same cone penetration test with the cone has a sensor by which you can measure the wave velocities. The energy impact is again created at the ground surface, and then you would measure the response. Now I move on to seismic refraction test. Here impact is generated at one point, and you have a series of geophones along a line. So it measures the primary and shear wave velocities. It determines the lithology, the overburden thickness, depth to rock, and weathering profile of the rock. Dynamic parameters such as shear modulus, Young's modulus, and Poisson's ratio can be determined. So here you would, to generate the P wave, you strike a plate on the ground with usually a 12-pound hammer. An explosive can also be used if you want to get the energy down to greater depths. To generate shear wave, a wooden plank coupled with the ground is struck horizontally. So the principle is that elastic waves are initiated at the ground surface, and the seismic waves travel along the discontinuities or the interface, and then they are refracted back to the ground level. The arrival time of the seismic energy is determined at a number of points along the line, along which the geophones are placed, and the travel time data is used to determine the primary wave and the shear waves and the depth of the layers. So this is the field setup where you have an impact and then you measure at the various geophones. So the impact gets refracted along this and you get the refracted wave. So you can see here how the you can see the geophone fixed along the line and a close-up of the geophone. Data acquisition being done here. The typical results, you can see the different layers, how they are varying. So you can interpret the lithology from the test. So the various layers can be interpreted along the line. So the advantages is that generalized stratigraphy over large areas can be quickly assessed. Identification of anomalous zones, fissured and fractured zones, shear zones, sinkholes, all these you can identify. Data can be used for dynamic analysis, and you don't need enough that many boreholes. You can do a few boreholes and then you can identify the trend of the variation of the layers. Limitations, of course, are there. The softer layer underlying a hard strata cannot be identified. Intermediate thin layers can be missed out. If the bedrock is undulating, interpretation of the layers can be misleading. Typical interpretation based on seismic refraction test. You can see here at NTPC Sundarnagar, we had identified the various layers and the velocity of the layers. And each of these layers we could interpret from the borehole data, that the deeper one is the saturated rock. I move on to SASW test. This again is similar to seismic refraction, but of course the geophones are slightly different which are used here. So again, no boreholes are required here. So you have an impact and then an array of geophones. So this is the system which is used to determine the analyze SASW. So a sledgehammer again used as a source. So you can see the geophones here. Now I come to energy measurement for SPT. This is the last section of my presentation here. All of you are aware of the conventional SPT system where you have a split spoon sampler and you hit with a normally you have a 75 to 200 mm diameter, usually 150 mm diameter holes. So this split spoon sampler, 50 mm diameter. The hammer weight is 63.5 kg and the height of fall is 750 mm. So you drive it by first 150 mm, so those blows are ignored, and then further you drive it by another 30 centimeter, record the blows every 15 centimeter, and the sum of the last two blows is taken as the SPT value. Now standardization of the SPT value becomes very critical because non-standard SPT systems may deliver highly variable energy values to the drive rod. The energy transfer affects the N value. So if the energy transfer is erratic, the measured N value will not be realistic. So the soil strength, safe bearing pressure, foundation settlement, and other geotechnical parameters are usually based on the average N value. So lower energy will yield in higher N, result in a high N value, leading to unsafe predictions. High energy could result in over-design. So you must obtain a normalized N60, which is 60% efficiency for reliable foundation analysis. Liquefaction potential also uses N60, which is 60% efficiency. So the SPT analyzer is a very effective way of doing this. Here you have an instrumented rod which is used at the top, and with the analyzer you have a accelerometer and a strain gauge fixed at the top. Energy calibration will normalize the energy transfer to the SPT sampler and help standardize the test. It will remove the scatter in the values and thus enhance the reliability of the data. Energy calibration should be made for each rig, which will have different types of driving systems and skill of the operator. It should be standardized to 60% energy transfer so that all the correlations which are used with N, they can still be valid. IS 2131 and 1893 shall be similar in while addressing these specifications and corrections. The code, of course, IS 2131 does not have energy correction, but energy calibration. But the code is under revision, and hopefully this will be introduced in the code very soon. ASTM, of course, has a energy calibration is advised. So with this, I come to the conclusion of this presentation. In conjunction with boreholes, in situ tests such as pressure meter tests and static cone penetration tests, load tests, etc., they can, as well as geophysical tests, these can confirm the continuity of the strata, evaluate the stratigraphy, and determine the relevant parameters. The advanced testing technologies can provide useful data for foundation analysis. It can economize the foundation design, make the predictions more realistic, so that we can have a better control on the foundation behavior. The testing procedure, testing program should aim on saving time and cost of investigation while improving the reliability of data. It should also aim on ingenuity and careful planning is including appropriate tests to evaluate the problems is very much essential so that you can optimize the foundation design. Thank you very much for your kind attention. I shall be happy to take questions. Thank you.
Thank you, sir. Thank you very much for the kind lecture of yours. It started from the very basics and connected it to the field testing as well. We talked a lot about you talked a lot about the advanced testing required in this field. So, with your kind permission, can we go on to the query round?
Yes, please.
Thank you, sir. So, if any of the participants want to ask questions directly to the sir, they can unmute themselves and ask the questions.
I don't know whether I went above their heads or it was too elementary. But,
they're not in the chat box. Sir, I had a few questions coming from students with me. So,
yes.
Shall I narrate them?
Please.
One of them has asked, what is the difference between striking the hammer vertically or horizontally in seismic refraction test?
Oh, the vertical striking is used for the primary wave velocity, and the horizontal striking is used for the shear wave velocity measurement.
Okay, I hope that will solve the query. Sir, another question we have. Can we comment on the mineralogy based on the geophysical test?
Well, electrical resistivity test gives you an idea of the resistivity of the ground, and you will have to compare them with the published values in literature to identify the rock type or the soil type. And then, of course, mineralogy cannot be assessed. If you can, you would have to know much more about the geology of the area to know what type of rock it is, and then test the material for mineralogy. It can only give you a guidance as to if you are in Shimla, I know what kind of rock we should be getting there, and if you are in Delhi, I know that there would be quartzite here. So depending on that, where I am and the kind of rock that is likely to be met, you should be able to make an assessment of the mineralogy.
Yes. Sir, there is another question again regarding the cross-hole test. How the cross-hole and down-hole test results differ?
How they differ. The downhole is a little cheaper because you need only one borehole, and whereas crosshole requires 3 boreholes. So there is an additional cost of 2 boreholes. More reliable data is from the crosshole because you get the data at the same level. Whereas in a downhole test, you would get the average properties from the ground level where the impact is made to the level at which the where the boreholes are being where you are doing the test. So that would be an average property. So obviously it will help in getting the specific property at that particular level. You would have to go for crosshole test.
Okay, sir. Thank you very much. So there is another question from Jitendra Raul. Namaskar, sir. It's a very nice presentation. If presentation will contain short videos of the test, it will help us a lot. That's a suggestion, I suppose.
Yes, thank you very much for the suggestion. We will include some videos if possible in the future presentations. There are 4 more presentations due.
There is another question from Kiran K. May I know the significance of VS30? Why only at 30 meter?
VS30, what is that?
I think that's the shear velocity, I suppose.
Shear wave velocity is measured at all depths. Why not? It's not only at 30 meter. I did not mention anything specific about 30 meters in my presentation.
Kiranji, are you here? Can you please further specify your question?
A typical case study which I had, data which I had presented here, that was up to 30 meters. But of course, you could have any kind of, it would depend on the depth at which you would do it.
Yes, I think, yes, now he's satisfied.
Okay, thank you.
Okay, sir, I do not get any, okay, there is another query. So this is REG pressure meter test.
Yeah.
It is not possible to test in sandy soils due to borehole collapse. In weathered rocks, there is high chance of damage of probe. The question is for hardy stratum like SPT and value more than 100. What is the necessity of pressure meter test then?
Okay, now as far as a pressure meter test in sand is concerned, it is not possible is not the answer. There are some limitations. We have to be very careful, and it has to be very carefully done to make sure that you are able to do the test. In sand, it could be challenging. Of course, in loose sands, only the boreholes will collapse. In dense sands, they may not collapse. As far as hard strata fractured rocks is concerned, you see, it depends on what your application is. Now, there are some very heavily loaded facilities, particularly like you are aware of these new bridges which are coming up, which are a large span. Similarly, nuclear facilities which are very heavily loaded. You may want some of the parameters in the fractured rocks, in the hard rocks. And for normal kind of buildings which are maybe 10, 15 stories, it may not be required. But you have to carefully look at what your application is. And if you are going to have a bridge across a river like Brahmaputra, where the currents are very high and the water depth is also substantial, you could have very high stresses in the rock if you are having a pile or a well foundation seated in that rock.
Thank you, sir. There have been a lot of comments. People really liked your lecture, and a lot of had commented a nice and very informative presentation. There are a few more comments now. Dr. Chen Gupta, namaskar, sir. First of all, very congratulations to the team for arranging such a nice session. Thank you, sir. Sir, I want to know which type of tests are supposed to be used in soil having fracture rock on shallow depth. It is possible to apply SPT test on that situation or not?
In fractured rock, you would usually get SPT value of much greater than 100. It will not give you very good results. What I would suggest is that you should go in for drilling with the triple tube core barrel, so that you get a good recovery of the rock, and then you know the what kind of jointing is there. Seismic refraction test could also tell you up to what depth the rock is fractured and below what depth you are getting stronger rock. And then, of course, it is not just the strata. You would also depends on what you are constructing on top of it. So, depending on that, the various testing scheme has to be worked out.
Okay, so there is another question from Amit Kumar Mandal. Very informative, comprehensive, and useful presentation. How does to get the in situ shear strength of the hard clay with SPT more than 30 foundation strata, as the UDS is usually not collected due to the occurrence of disturbances while sampling in the hard clay strata? Can the pressure meter test or any other suitable field test can be done in this case? Please discuss.
Pressure meter test is the ideal test for this application because pressure meter test is going to give you very confirmatory parameters. From there are correlations available between the limit pressure and the shear strength of the clay, and these are very well published and documented. So once you know the limit pressure and the modulus of elasticity, you can work out the shear strength, you can work out the over consolidation ratio, and all these other parameters from the pressure meter test. It's a very useful test.
Okay, I hope that will solve the query. There is another one from Sudhir Bhatsi. He's asking that resistivity may vary with moisture content and should be specified with it. Please clarify.
I agree with you. Resistivity will vary with the moisture content, and the season during which you do the test matters because in dry season you could have high resistivities, and during the monsoons particularly the superficial soils could have a lower resistivity. So you have to interpret it considering the level of the water table, because you would have to do it along with boreholes, so that you know what the borehole data is and how you can match the resistivity data with it.
Okay, sir. Sir, I think that's it. We are done with the question and answers.
Okay, so the next presentation will be next Saturday, in which cone penetration test will be discussed in detail. Each of these tests, actually, what I have given today is just a brief introduction, and just try to tell you that these kind of tests are available, and you'd have to do a little bit more study on each of these tests to be able to, figure out where it is applicable and how best you can do it. That's about all I have to say. I see Pravaram Panda has raised his hand. If there anything which you would like to say.
So any of the participants want to ask the question, they can kindly unmute themselves and directly ask the question. Sir, I don't feel there are any other left. So, sir, with this, I would like to thank you once again for your kind gesture, sir. And with all your support, it has been possible to organize this entire lecture series. And we are also grateful to you that we'll be meeting you once again on 10th of October, 3:30 p.m. And we'll be continuing with this lecture series. So next lecture will be on next Saturday, given by Mr. Saurav Gupta, Managing Director of Cengrs Geotechnica Limited, on 25 September from 3:30 p.m. onwards. And I would also request all the participants to please fill out the feedback form before leaving. So thank you to all the
participants. Thank you, sir.
And thank you, sir.
Really very grateful for all this great gesture. With your permission, now I would like to leave the call.
Yes, sir. Surely. Thank you. Thank you very much.
So thank you, sir.
Thank you very much.
So thank you to all the participants. We hope we'll be joining again with us on the very next Saturday at 3:30 p.m.
Please feel free to contact us in case of any query. We will be happy to help you. Thank you.
Thank you, everyone.
Temos mais tagação por alonga lá. Temos mais tagação por alonga. Sabe que não vamos sim, diz. Você é mais uma piada de alonga, diz. Pode,